Okay, so I want to discuss the midpoint rule. Sorry about that. Okay, here we go. I was confused. Okay, so we've got the midpoint rule. That's what I wanted to have. And here's the formula. So the formula for the midpoint rule is right here. So I wanted to explain what all of these symbols mean, right? What does it mean? Now we said that our delta x is equal to b minus a over n, and xi, x sub I, with a bar over it, is the midpoint of the ith subinterval. So let's just unwrap this equation. So first of all, what are we starting off with? In order to use the midpoint rule, that means you've got to have an n, you've got to have a function f, right? And you've got to have some endpoints, a and b. So let's get started by just putting these into our picture here. So we're just going to assume this is a graph of y equals f of x, right? Y equals f of x is this graph here. And then we're just going to suppose we're starting at A and stopping at B. Actually, it might be better for me to just kind of draw some lines here. So like maybe that's A and that's B. Okay, does everybody get that? So B is here, A is here. And we have an interval. Our interval from A to B is from here to here. So we're looking at our function f over this interval A to B. Now what is n? N tells us the number of subintervals, essentially. Now our goal, if we're trying to estimate the integral from A to B of f of x dx, right? How we'll do it is for m sub n, take your interval AB and divide it into n subintervals. So for example, if n is equal to 6, I'm going to take my interval and divide it into 6 subintervals. So it looks like it'd be maybe 1, 2, 3, 4, 5. Okay, let's pretend I said n equals 5. Okay. Now, so everyone see how I've got 5 subintervals. This is a subinterval. That's my first subinterval. My second subinterval. My third subinterval. My fourth subinterval. My fifth wait, 1, 2, 3, 4, 5, 6. Oh, I do have 6 subintervals. Sorry. 6 subintervals. Okay. Now, A is the notation is also equal to x sub 0. This first endpoint is x sub 1, x sub 2, x sub 3, x sub 4, x sub 5, and then B is x sub 6. Okay? Now, for our formula, if you look over here, we've got xi bar, right? So for us, what is xi bar? Xi bar is going to be the midpoint of the ith subinterval. So x1 bar is the midpoint of the first subinterval. So it'd be like about right here. So it'd be x1 bar. x2 bar is the midpoint of the second subinterval, right? x3 bar, x4 bar, x5 bar, x6 bar. So here's what this formula means. What this formula means is, because remember, this form, m sub n, is supposed to estimate this integral from a to b f of x dx, right? So here's how it does it. Essentially what we're doing is we're saying, take the midpoint of each subinterval and use that to estimate the area. So we'd have something like this. Okay, Now, what about this midpoint for this for the second subinterval? Okay, so let's go across and up. Okay, now what about the third subinterval? So we are using rectangles to approximate the area, if that makes sense. And then this midpoint here, which will give us here.
It's 2015.
And then finally this one. Okay, so if it helps any, in this case, right, so for us, we've got n is equal to 6. So m sub 6 is equal to the area of those 6 rectangles, the height of each rectangle. What's the height of each rectangle? The height of each rectangle is determined by the value f of x bar sub I, right? So for each, what is the area of these 6 rectangles? We want the height of the rectangle times the width of the rectangle. So this is the height times the width. What's the width of each rectangle? Well, to get the width of each rectangle, it's going to be the same width, right? Because we took our interval and we divided it into 6 equivalent subintervals. So how do we find the length of the interval? The length of the original interval is going to be b minus a is the length of the original length of the interval of integration from a to b, right? Because you know how we're starting at a and stopping at b. So how long is this interval? B minus a. So if the entire interval has a length b minus a, what's the length of each rectangle? It's going to be b minus a over n. So that is exactly the same as the delta x. So delta x represents the width of the rectangle that we use to approximate the area under the curve over that subinterval. Okay, so we're talking about f of x bar sub I times delta x. This is the area of the ith rectangle. And so what do we want to do? We want to add up the areas of the ith rectangles. You start off with I equals 1, stop at n. Right, and so this is how we get our formula for m sub n. So essentially, what is it? It's saying add up the area of these rectangles. How do you figure out the area of each rectangle? The height comes from the value of the function at the midpoint of the interval, and the width is going to be uniform, right? And it's just going to be the width of the entire interval from a to b divided by the number of rectangles.